This is Sukruti Joshi. Our today's topic for this particular video session is Meyer reaction and its applications. So we will see here that what is actually Meyer reaction. Now, in chemistry or in different types of chemistry, we all know that we have many name reactions. This kind of name reactions actually plays a very important role in deciding different synthesis of materials, or even they plays a very important role in the determination of the structure of that particular material, because the type of reaction that we will use or the type of reaction that we will follow, that decides the amount of product and that also decides the structure of that product. So which product will be formed with which name reaction, that plays a very important role. And we have here Meyer reaction. So what is the actual meaning of it and why it is widely used? So Meyer reaction is a type of substitution reaction that is widely used in the production of aryl halides from aryl diazonium salts. Now here in chemistry we have different types of chemical reactions like addition reaction, substitution reaction, elimination reaction, then we will have rearrangement reaction and polymerization reaction. So from all of that, one of the most important reaction which we all know is substitution reaction. So what is the meaning of substitution reaction? Basically, in substitution reaction, one atom or one particular functional group will be entered in the substance or will be substituted or will be there in our product, while one particular atom or one particular functional group will be removed from that particular atom. So one atom or one group will substitute another atom and another group. Okay, so that is a kind of substitution reaction. And here what we will do is, it is widely used for the production of aryl halides from aryl diazonium salts. So it is a kind of substitution reaction. Now here copper salts like chloride, bromide, that is either cuprous chloride or copper chloride, copper bromide or copper iodide ions are used as catalysts in this particular reaction. So we need to make sure that particular catalyst has to be used here. So in this substitution reaction is supported by catalyst, and which catalyst we will use here? We will either use CuCl2, we will either use CuBr2, CuI2 or any other kind of copper salt. So they will play a very important role in this particular reaction. Okay, so here the Meyer reaction can be used to perform unique transformations on benzene. So the transformations here that we will include, it can be hydroxylation, it can be trifluoromethylation and cyanation, and the last one is halogenation. Okay, so what we will have here is, basically we will do the transformation of benzene. So we will do the reaction on benzenes. Okay, and which kind of reactions will be there? So we will have here hydroxylation, trifluoromethylation, cyanation, halogenation, etc. Okay, the transformations include hydroxylation, trifluoromethylation, cyanation and halogenation. Here the halogenation also includes chlorides or chlorination, bromination, iodination, etc. Okay, so the reaction was first discovered in the year 1884 when Robert Meyer, who is a Swiss chemist, was conducting an experiment to synthesize phenylacetylene from benzene diazonium chloride and cuprous acetylide. So here, however, at the end of that particular experiment, the obtained phenyl chloride as the main product. However, at the end of experiment, what we get is basically the phenyl chloride. So Sand-Meyer reaction is believed to be a great example of radical nucleophilic aromatic substitution. So it is basically a kind of free radical nucleophilic aromatic substitution reaction. Okay, so it follows either SN1 or SN2 depending upon the particular type of reaction it will have. So we will have either nucleophilic substitution reaction number 1 and nucleophilic substitution reaction number 2. This reaction is useful tool by which an amino group on an aromatic ring can be replaced with different substitutes. So what we will do here, the aromatic ring will be replaced with different substituents. And which substituents we will use here? So it is basically a radical. So a radical will be substituted on that particular ring. Okay. So during the Sand-Meyer reaction, the amino group that is attached to an aromatic ring is converted into diazonium salt that can be transformed into various functional groups. So what we will do here, the first of all, it is a group with which an amino group on an aromatic ring is replaced by other substituents. So what we will do here, we will have here the benzene on which an amino group is there, and that particular one. Okay, so understood it very clearly. What we will have here is basically we replace that amino group with any other substituent. Okay, so in this manner we will do this. Now let's see what is the mechanism of Sand-Meyer reaction. In every name reaction, each and every mechanism plays a very important role. So here the Sand-Meyer reaction follows a free radical mechanism. So it follows a free radical nucleophilic substitution mechanism. The reaction is actually a two-step process. As I said you, it can be SN1 also. So it's a two-step process where the synthesis of aryl halides from primary aryl amines involves the formation of diazonium salts and the transformation of diazo intermediates into aryl halides. So a displacement with a nucleophile occurs here. So it is basically a kind of substitution reaction in which one or amino group will be substituted by another nucleophile. Interestingly, the nucleophile can be halide anion, it can be cyanide, it can be water, etc. To understand further, the Sand-Meyer reaction mechanism commences with a transfer of single electron from the copper to diazonium. Now this results in the formation of non-participating diazo radical as well as copper to halide. That means here the oxidation or the state will be 2. So copper to halide. A molecule of nitrogen gas is then released by the diazo radical to give aryl radical, which then reacts with the copper halide to restore the catalyst, which is copper halide again. After all of this, the final product aryl halide is obtained. Now see here. Here the mechanism is shown. So in general mechanism, how it will be done and how you can understand this particular reaction. So what we will have here is, we will have an aromatic ring. As you can see, we have a benzene ring. Above it we have N2+. Okay, So an amino group will be there. It also consists of any alkyl group. So R is already there on that particular ring. Now it will react with Cu plus. Okay. So when it will react with Cu plus, at that time the N2 group will be removed. So that amino group will be removed. So when it is removed, at that time it will make it a free radical at that particular point. So free radical containing aromatic ring plus an alkyl group is there on it. As you can see in the image, it has R on it plus Cu plus 2. Right? So Cu plus will get converted itself into Cu plus 2. Now this particular structure that we obtain, a free radical aromatic ring structure, that again reacts with any halide group. Okay, understood it very clearly. Okay, so it is basically halide group. It reacts with halide group. So X minus, it will react with X minus, and that X group will substitute your free radical and will join at the position where earlier the amino group will be there. So as you can see in the image, benzene ring which contains R on it and N on it gets substituted with X. So X is, so it becomes basically the halogen containing aromatic ring plus one electron will be released. So that electron will be accepted then by Cu plus 2 and gets converted to Cu plus. Okay, so in this manner, generally the reaction, the common substitution or the common Meyer reaction occurs. This is all for this session. Next we will see in our next session. Thank you so much everyone.